Jaws production.
What are linear functions? Linear functions can be defined in the equation f of x equals m times x minus h plus k, where the m does not equal 0. The domain is a set of values for which a function or relation is defined, and in this case, it's all real numbers. On the contrary, the range is a set of y values of a function or relation, and in this case, it's the exact same as domain, all real numbers. The parent function is y equals x, where the x and y intercepts are represented as 0, 0. Now you're probably wondering, what is the relative minima and maxima of linear functions? Well, there is none. Symmetry can be defined as taking an object and cutting it into two equal parts. For linear functions, the x-axis cuts only vertical lines, the y-axis cuts only horizontal lines, and the origin cuts through y equals x.
It's an odd function.
There are no asymptotes. For the end behavior to result in a positive slope, as f of x approaches negative infinity, so does x, and vice versa. In the regards of a negative slope, as f of x approaches negative infinity, x approaches positive infinity, and vice versa. A vertical shift results in the line moving across the y-axis, while a horizontal shift results in the line moving across the x-axis. Vertical shift goes up and down, and horizontal shift goes left and right. Reflection over the y-axis is y equals negative x, and reflection over the x-axis is negative y equals x. Linear functions are the simplest models to make, and they are literally everywhere. Literally.
Now, moving on to absolute values. The format of it is y equals a times the absolute value of x minus h plus k.
The domain of absolute values include all real numbers.
The range of the parent function is from 0 to positive infinity.
The xy intercepts for the parent function is at 0, 0.
For positive parent functions, the minima is at 0, 0, while there is no maxima.
In the case of a negative parent function, the minima doesn't exist while the maxima is at 0, 0.
Symmetry about the y-axis is shown through y equals absolute value of x, while symmetry about the x-axis is shown through absolute value of y equal to x.
Absolute values are even functions. There is no asymptote.
The end behavior of the parent function is f of x approaches infinity as x approaches infinity, and f of x approaches infinity as x approaches negative infinity.
Transformations. Horizontal shifts, y equals absolute value of x minus h. Vertical shifts, y equals absolute value of x plus k. Reflection across the x-axis, y equals negative absolute value of x. Reflection across the y-axis, y equals absolute value of negative x, which is basically the same as f of x equals f of negative x, which is an even function, which is the parent function. Vertical stretch, y equals m times the absolute value of x when m is greater than 1. Vertical shrink, y equals m times the absolute value of x when m is less than 1. Horizontal stretch, y equals absolute value of n times x when m is less than 1. Horizontal shrink, y equals the absolute value of n times x when m is greater than 1. Now you may be asking, How can I apply this to my real life? You aren't asking that? Screw you, we're gonna tell you anyway. Absolute values are generally used in the context of speed, distance, and time. As for there is no such thing as negative speed, negative distance, or negative time. But what if that's just what the government wants us to think? What if negative distance allows us to travel to other universes? What if negative time allows us to go backwards? What if?